then we're going to finish the dynamic analysis, mainly the portrait frequency. So we have gone through this single European system. Yesterday, last week we also gone through the 2 European system. So the idea of doing force vibrations is you have to add inertial force on the node where the mass is located. For example, I now have 2 springs and 2 mass. Okay? When this is subjected to harmonic forces or harmonic vibrations, the inertia of the mass is non-zero. Okay? So as a result, when you're writing the force summations, you have to convert the spring forces, you have to convert the acceleration into the inertial force. Take for example, if you're writing Newton's second law, you're writing mass and acceleration is equal to the force summation. But here we are writing all the force summation minus the inertial force. So when acceleration is going downward, okay, the inertial force, when you write in the force balance form, Newton's first law form, it's got to be written as minus inertial force. Okay, minus mass and acceleration. Likewise for the third mass. Okay, see here the third mass. So you have a spring force opposing the downward displacement U3 relative to U2. So that's why we write minus 2k U3 minus U2. This is the spring forces, okay, coming from this lower spring. And then minus away the inertial force. When you have the mass accelerating upward, then your inertial force is going to be upward when you are writing in the force balance form. 所以之前我们教你们那个写牛顿定律，一般会写质量乘上加速度等于 y 力。OK， 不过你现在有些人写的时候你是静力平衡，所以你要用静力平衡写成牛顿界定律。唯一的做法就是把就是质量乘上加速度，这个是叫做一个惯性力，移到了那个力那边的方向，所以这个是变成惯性力。Okay? So if you're going to solve it, okay, you're going to write them in the matrix form. So these are the 3 force balance. Okay. So how do you write the force balance? For each knot, you have 1 force balance. First at the anchor, second at the mass, and then third on the lower mass. So you now have the 3 equations. Okay? Then you're going to rewrite them in such a way that you have acceleration term times mass matrix, displacement term times the stiffness matrix. They all sum up to become so-called the reaction force or real external forces. Okay? So this one excluding the harmonic forces yet. Okay? But later, okay, if you are substituting in the non-displacement, then you reduce the 3 equations into 2 equations. Okay? And in the absence of the weight, okay, when you're talking about harmonic vibration, you're talking about vibration about the equilibrium position. Okay? 当你要做那个模态或者是模态分析的时候 ，OK， 你要查找的振动不是从V加载到最大的 V 定位的振动，你是计算在那个平衡位置上的振动的时候，你这个静力就会被你的那个取消掉，只剩下动力。Okay, in this case, when you do the substitution of the harmonic displacement, okay, so if you do the substitution of the harmonic displacement, okay, and then do the acceleration twice, then you found out the acceleration is actually minus omega n squared the displacement vector. So in this way, when you do the substitution back into the equations, you have this simple form of equations with a common factor of amplitude times sine. What is it inside here is your system matrix. In this equation, clearly you can see the right hand side has zero force. You're going to have zero amplitude of vibration, but you are not allowing zero amplitude of vibration, otherwise the solution will be trivial. So in order to do so, when you are applying Hammond's rule, even though the numerator is zero, you force the denominator to zero. So that, okay, you can find out the critical condition of so-called the frequency equations, okay, when the amplitude is not zero. 从这个第四二元方程式，你右手向你这个力是零，很肯定的，你的整动的幅值，如果马上求解的话，你幅值为零，但是这不是整动的情况，整动的情况你幅值非零，所以唯一能够找到非零的正幅的时候，唯一一个条件就是分母为零。所以这分母为零基本上是拿你的系统矩阵的行列是设定为零，这个时候你就会找到你的这个共振频率。Okay, so this is how you find the natural frequency. Okay, so make sure you are able to do this. Okay, yeah. So this is how you find the natural frequency. So next thing I am going to explain you also is. You have mass here, mass there. This is your U2. This is your U1. Okay. Your equation is there. Okay, your equation is something like your system equation is your model is something like this. If you already find this equation, okay? If you already find this equation, what else you can do? Okay? So this one is your A1 sine omega t, and this one is your A2 sine omega t. Okay? Your system equation tells you have minus omega squared m plus 5k minus 2k minus 2k minus omega m plus 2k. Okay? This is your amplitude 1 and amplitude 2 equal to your zero force vector. We can use the determinant. Okay, basically determinant of this. You set it to be zero, then you can find your natural frequency. Natural frequency is found this way. Okay. So you expand this out, this is omega 4, then power 2 minus 7km omega squared, then this is plus 10k squared minus 4k squared. So you can clearly see this is the 6k squared. So you can do by these quadratic equations, or you can do the factoring. 你包括用意式分解，你都知道应该是这样的一个解法。所以你的 omega 有两个解，你的 omega 是第一个解是开根号 k 除以 m， 第二个解是开根号 6k 除以 m。Okay? So this is how you find your natural frequency. But next thing I'm going to ask you is, will you be able to find the Morse shape? Okay. Okay, 这整都是什么意思呢？这整都是，你看看，这是正负，它的频率是 ，OK， 50到50，它东西是一样的，但是 So now what we're interested to find out is, will you be able to find what is the relative amplitude? Okay, A2 over A1. Okay? Because for vibrations, okay, it could happen that you could move in phase. It could also happen that you move out phase. How do you find this ratio? If they move in phase, this is a positive value. If they move out phase, this is a negative value. Okay? 你现在有两个质量 ，OK， 它在振动，就好像这个跳舞一样，你可以同步，也可以不同步 ，OK。就同步的时候是相比它比例正，不同步的话它的比例是负。How to get this amplitude ratio? You can take the first equation, okay? How to get the first equation? You take the first equation by writing out this is minus omega square n plus 5k times A1 minus 2k A2. Okay? So you move this to the other side, and this one becomes equal. Now you can find the rate amplitude ratio A2 over A1 is then going to be minus omega square n divided by 2k plus 5 over 2. Okay? So now this is your amplitude ratio. Let's find at first frequency what's the amplitude ratio. 所以你现在要找的是模态，模态是怎么定义？模态基本上就是你这个整体的相对运动的一个趋势。如果两个质量，我们的运动趋势比较容易写，基本上就是写一个比值的相对比，相对一个参照点。就比如说你这个是不是 U1 你把它定义为1，这样 U2 的这个值是多少 ？OK， so if you now plug in the natural frequency, what's the first natural frequency? Omega squared is equal to k over m. So if you do that substitution, then you have kn times n over 2k plus 5 over 2. What's this ratio? This is actually minus half plus 5 over 2. So this is then equal to 2. Okay? So this is telling you if the amplitude here is 1 unit. Okay? I'm redrawing this. Okay? The middle mass moves by 1 unit. This is 1. And then the lower mass will move by 2A11. Okay? So this is the motion. Okay? So next, what happens if you are talking about the second natural frequency, omega squared equal to 6k over n. So this will then be minus 6k over n times n over 2k. This is then minus 3 plus 5 over 2. So this is then minus 1 over 2. So in the second mode, when the frequency go higher, 所以在第二阶，这频率快了多少？开根号6 ，OK， 开根号6大概就是2点多 ，OK， 所以如果它碰得了快 ，OK， if this is the high frequency, but maintaining an amplitude of 1, okay, what is the amplitude of the second mass? The amplitude of the second mass becoming minus. So whenever this displacement of mass one going down, this one going up, and then when it's going up, this one going down. So it's opposing. And somehow the amplitude is only half of the amplitude of the first mass. So that's the idea about motion. Okay. 所以如果同学不清楚什么叫模态，就拿一张纸来给大家做一个简介吧。看到没有？这张纸，你知道它折动的位置吗 ？OK， 如果是静态的，你看得到它的位置，但是动态的时候，你看到的是什么？它就是这个叫外包材，这个叫 envelope。So why you care about envelope? Okay, because it's vibration. You cannot know my hand position exactly. Okay? So take for example, you are seeing me waving my hand. Okay? If I'm moving in phase, can you recognize? If I'm moving out phase, can you recognize? OK， 为什么我们要用这个模态这个概念？因为动态的东西，你很难确定它的确实位置。OK， 但是相对位置你还找得到。OK， 所以我们就用这个辅值比。OK， 为什么用辅值？动态的东西我们为什么要用辅值？因为你肉眼上确切的位置找不到。OK， 比较贵的设备才找得到，所以但是你很清楚的知道哪里是最高点，哪里是最低点，所以你就用辅值的这个概念。So this is how you make use of your position. So if you are not sure what that means, then I can show you something interesting. So this is one of the work done by my student. Okay, long time back, I show you what can you do with the vibration isolated. 我看看 Just to give you some idea about resonance. OK， 如果你要做一个拍翼 ，if you are going to make one flapping wing mechanism, what you going to do? You don't have a muscle like bee has, but you have an electric motor. So what you usually do is you use a crank rotor to turn. Okay? But now, if I don't want to use the motor to drive the wheel, to use the flapping wing, what can I do? Okay? So this is the motion, crank rotor. 这个 crank rotor 就是跟脚踏车的机构一样，产生这种旋转，产生拍打的动作。Okay? But now what the insect has? What the insect has is the muscle contraction. 这个昆虫飞啊，一般上它的那个驱动机制，就好像两束肌肉，一束在它的这个昆虫的胸腔，就好像这个一个锅，然后胸腔之上有一个盖，就叫锅盖。OK， 所以你现在是翅膀是怎么开打的呢？它是用一个连杆机构。假设这是翅膀 ，OK， 这个是昆虫的这个胸腔，你只要把你的笔悬在旁边，然后这个锅盖压下去 ，OK， 如果压下去了过后，按昆虫的机构啊，这个笔就会翘上来，然后锅盖掀开的时候，这个翅膀就会往下降 ，OK。So the insect thorax is almost like a pod and a pod lid. The muscle is connecting the pod toward, it's connecting the pod lid toward the pod. When muscle contract, okay, so the pod lid is coming closer to the pod. So the wing, which is pivoted at the end of the pod, will then be beating up, okay. But muscle can only contract. 肌肉只能收缩。你这翅膀啊，打上来过后拉不回，OK， 你要另外一束肌肉。所以 insect, another set of the muscle is actually the longitudinal muscle. So this longitudinal muscle will be contracting to pop up the pod lid. Okay. So what we do, as inspired by this is, okay, we don't have the master, but we have the vibration motor. So we don't have a master, we now have an empty pot and a pot lid, okay, at the main base. So what we did is, we have the vibration motor that moves, creating the centrifugal force. So it's moving up and down. 所以你可以用共振的方式产生这个大的这个拍打的动作。OK， 这个频率大概应该是多少啊？看一下，频率是20赫兹。OK。So how do we manage to see by night? I'm not using high-speed camera. I'm taking a normal speed camera. Okay, but what I did change is I'm flashing my light at 20 hertz or slower or more so that I can do the freezing of the position. So this is to tell you if without this kind of help, flash, okay, so you will not be able to see the actual position. You only see the envelope, the maximum position and the minimum position. In between, all will be blurring out. OK， 你如果不是因为有这个定时快速的闪光 ，OK， 这个拍打1秒钟20下的拍打，你根本看不到它确的位置，你只能看到它的最峰值跟谷值，中间位置就全部看不到。所以我们是借助这个打光的方式，你要1秒钟，这个你的闪光要闪这个20下，你才可以让你的这个变成慢的。This is what we call a stroboscope, and this is the effect of resonance. Okay, and here, what will be the mode shape that you will be tracking? Okay, the mode shape that you are tracking is the motor position, up and down, and the wing position, hitting up and down. Okay, hitting clockwise and counterclockwise. So this is a translation, this is the conversion from linear motion into angular motion. 这是从一个线性的位移转换成是角位移。OK， 所以这个是大概跟大家介绍一下这个自然频率跟共振频率跟这个模态的关系。Okay, so now we come to next thing. Okay, next thing that we're going to study is what happens if you now have a continuum mass. Okay, what you see here, these are what you call lump mass. Okay, 你的质量就在节点上。Okay, 1、2、3。Okay, but in reality, mass is distributed along the length. How would you make sure? So now you have a rock. Mass is distributed along the length. How do you distribute the mass into the nodes? Okay. Then we need to make use of the sum of concept. Basic idea is simple. We are using the kinetic energy. Okay. You may forget about the gravity equation because we're not going to use gravity equation to derive. There might be interpolations. Okay. Okay, 可是我简单写一下。Okay, how are you going to write the expressions so that you can get the inertial force? Okay. Okay, let me write the inertial force first. 现在其实做法比较简单，我们基本上比较找等效质量。Okay. Okay, now if you consider only one rock, okay, how do you analyze the displacement? Okay, your displacement, if you now have this, okay, U1, this is a U2, okay, I rotate them so that I can see them in everything. Okay, if I rotate them. Okay, so your displacement will be increasing. Let's say this one is anchor. Okay, this one will be near to zero. Okay, but if it's slightly more, okay, how do you write the displacement here? Okay, the displacement at any point. 如果是在这个 y 位置，这个速度这个位移是多少？好 ，OK， 我放一个 s， 好，大家问一下。If this is the position s, what will be the displacement? You have learned about the shape function already, isn't it? So according to the shape functions, you should have n1. Okay, let me put x. n1x u1 plus n2x u2. What is your n1, n2? Your n1, n2 is just a shape function. n1 is 1 when x is x1. Okay? n2, but n1 is 0 when x is x2. Okay? Likewise, if you are talking about n2, okay, n2 is 1 when x is x2. When x is x1, n2 is 0. Okay? So what makes this n1? Okay? You can write down. It's going to be 1 minus x over L. If this is the element length. Okay? Okay. 然后这个呢，就是 x over L. So this is what you have for your velocity. Okay? This is what you have for your displacement. We're going to next find out the velocity. Okay? Because we are assuming the profile won't change. Okay? So what you can now write is u dot x is equal to n1x times u1 dot plus n2x u2 dot. Okay? 所以看到没有？所以你们现在找的是这个叫动能 ，OK？ 然后你的加速度呢？我们在找加速度。Likewise, if you are talking about acceleration, it's only the nodal acceleration method. Okay? To find out the equivalent force, what we're going to find is the kinetic energy. Okay? So what is the total kinetic energy of this system? The total kinetic energy of this system will be, okay, the small mass divided by 2 times the exact velocity. Okay? You understand this? Then what you can write next? What you can write next is, what is your dm? Your dm is rho a dx. Okay? And times the velocity squared. And then if I now expanding it out, you'll be half rho a velocity squared dx. What is your velocity squared? Your velocity squared is, you write this up. What's your velocity squared? This one will be your your N1, N2, U1, U2. Okay? So this square is basically U dot transpose U dot. What is your U dot transpose U dot? It is then your U1, U2 row times your N1, N2 times your N1, N2 times your U1, U2。OK， 看到没有？这个矩阵现在就写成那个形式了。OK， 你的能量是多少 ？What is your energy? How much is your energy? Of course, if you want to expand it out, it's also doable. If you do expansion out, we have UN plus U2N2. If you're just doing the square, so you have U1 square, N1 square, plus UN, U2, N1, N2, and then plus U2, U1, N2, N1, and then plus your U2 square, N2 square. Okay? 看到没有？你这是基本的展开，但写成矩阵的形式，写成矩阵的形式是什么？写成矩阵的形式，它就变成是 U1、U2， 然后这个是什么 ？N1 square, N1, N2, and then N1, N2, and then N2 square. 这个部分变成是内部要积分的那个部分。So you can see that this is convertible, okay? But eventually, what you are interested, okay? You can do so for your acceleration, okay? And you can do so also for your energy expression, okay? 我们来看一下，你要等效成什么？ So based on this, we now give a name to our matrices. OK， 你通过这个方式，给我把它展开来，这个写出来 ，U1, U2, and half row A integral. Okay, and I can put the U and V outside. U and U2 outside. So now we have a name for this matrix. And we call this a mass matrix. Okay. 所以你还记得你的这个 K 矩阵吗？ So look at your rod. In the static case, you are writing force 1, force 2 is equal to K minus K minus K, K, and then U1, U2. 对不对 ？OK， 然后 ，OK， 你如果是有动态的位，okay? If now you have the acceleration, what are you going to write? Okay? What you are going to write is the minus inertial force. What you're going to write here is minus, this is external force, this is the spring forces, which was supposed to be the other side. Huh? Then now you are writing this plus your, what is it? Your integral of n1 squared. OK， 这个我们就不用2了，为什么呢？这个是动能 ，OK， 所以我们只要这个一的部分，我们只要等这样子的 ，rho a n1 square n1 n2 n1 n2 n2 square and then dx times the acceleration u1 double dot u2 double dot。OK， 这个题是大家可能可以记一下，这个是力等于你的外力等于弹力乘上位移，加上你的教质量乘上加速度。So now what we can write now, okay? What we can write now is we're going to find out what is the equivalent mass. Okay? So you can have, we're going to do integration one by one. What is the integration of n1 squared dx? Remember your n1. Your n1 is 1 minus x over L squared. And then the x starting from 0 to L. So this is then 1 minus 2x over L plus x squared over L squared. And then the x. Okay? So if you do the integration, then you got your x, you got your x squared over L, you got your x cubed over 2L squared. And then integral from x equal to 0 to x equal to L. So now you have L, you have minus L, and then you have this, okay, I forget to do this, huh? This is divided by 3. Okay? So 这个是除以3，所以这就变成这个 L 除以3，对，所以你的，给答案我们看一下。OK， 就是3分之一 L。Okay， so we have done this. So next, what are we going to do? So we have this becoming L over 3. Okay. Next we're going to do with n2 squared. n2 squared is x squared L squared. This is only this term. Only this term. And then this is only L over 3. Then next, we're going to have n1, n2. So n1 and n2 is 1 minus x over L times x over L. So what do you have then? You then have x over L minus x squared over L squared. And then this one you have the x squared over 2L. And then minus x cubed over 3L. Upon substitution of the L, then you have L over 2 minus L over 3. So in the end, you have L over 6. So likewise, you do the rest. This is L over 6. This is L over 6. So in this way, we can find out our stiffness mass matrix after the integration. And what's the name we have for this matrix? We call it consistent mass matrix. OK， 你看到没有？这个质量很特别，特别在哪里？你不是把它放在两个节点上，你这个质量就是这个 F， 你不是把它归在，你不是把它归在 n 除以2 ，OK？ 你还相对的把它的相对比给关联住。不过有一个特点，你如果把一列的质量加总起来，它真的就是 n 除以2，加总起来丢到这个斜边线，OK， 加总起来加到斜边线，OK， 那这个就是 n 除以2。So this is how you derive the mass matrix. Okay. So let me continue the slide. OK， 今天我们上的方法跟之前的比较简化，所以我们把这个现象再跟数学关联。Okay, what you see here? Okay, for the sake of understanding, I'm going to remove this Gallatin method all out. Okay, so I only care about the I'm only using this expression. That is就是从动量的定义，然后弄出了一个这个叫 mass matrix，OK， 而是 mass matrix， 你去求解。把它摆在那一边 ，OK， 然后你就得到了这个质量矩阵 ，OK，Rho AL over 6，OK， 2 times 2 1，OK， so now you have the system equation. So how do you find the natural frequency? 所以我们就看最简单的这样的一个单元，你怎样去找它的这个自然频率。So this is a two-degree freedom system, free, okay? So how do we find the natural frequency? Okay, so now what you have is, you have your K, okay, let me put it there. So you have this, n over 3, n over 6, n over 6, n over 3 times the acceleration U1 double dot, U2 double dot, plus your K minus K minus K, K, and then your U1, U2. Okay? If you assume harmonic solutions, you can find minus omega squared m over 3 plus K, and then this is minus omega squared n over 6 minus K. Okay? And then this one is minus omega squared n over 6 plus K. Sorry, this is minus. And then this one is minus omega squared n over 3 plus K.